Hi everyone. Hi, my name is Maqbool and I'm from New Delhi, India. And I was super excited. I'm super excited about Elixir conference. And before I start my talk, I want to thank the volunteers of Elixir conference who made it possible for me to give this lightning talk, and especially the organizer, Dr. Jim Friz. He's a really nice guy who helped me a lot while I was emailing him about. So Lambda calculation, some funny looking character. So this character is used to represent the numeral 5 in Hindi. And I am at Maqboolism on Twitter. So starting with this brilliant mathematician, Alondra Church, he's the guy behind the idea of lambda calculus, which is the theoretical foundation for functional programming languages like Elixir, Erlang, or Haskell ML. And he also was the one of the PhD advisor of very famous guy, famous computer scientist. I mean Alan Turing. I mean this Alan Turing. Uh, so these guys has proposed this Church Turing thesis, which is exactly the main ideas are this. In 1936, they have like come up with a like people was wanted to formalize the definition of algorithms. So when they so Alondra Church used its lambda calculus to define the what's algorithms is and try to formalize using this notion of using lambda calculus. And Alan Turing used its Turing machine to define the algorithms, which is we all know the algorithm as informal as a step-by-step instruction, but we here try to formalize it. And it turns out that this from this thesis that both of those ideas and both of those abstract models are equivalent. And let's look at the syntax of the lambda calculus. It's a variable is a lambda expression, or in which we use uppercase letters for variables like a, b, z, x, whatever you can use for a as a variable. And and m are the lambda expression. Then so each of the following, uh, it's a lambda expression. You use parentheses to say, and then use the lambda abstraction operator, and then pass our formal parameter id here, and our the m is the body, and we then apply the n on m. In this case, where application we applying the lambda calculus in it. Let's look at the abstract syntax tree of this particular lambda expression, lambda 3. So in this abstract syntax tree, there is an application operator here, apply, and this abstraction operator called lambda. On the left hand side of the lambda, it's the formal parameter, and in the application side of the it's a 3 that which is actually a argument to this lambda, and it got applied, so it's transformed into something like this, and you can think of it's going to be calculated as 4. So uh, using this lambda calculus, you can define pretty much programming languages like logical operators. So logical operators could be defined something like lambda, which takes two arguments a and b and returns the first one. For false case, take the two argument again, and the similarly you can verify that it actually works. It's the attendee's homework, and for the and operator, it's take, and similarly it's returns, and the same is the case with the or operators. Similarly, you can use this also to something called the church numerals or numbers to represent. So one is represented by this lambda expression, and two and three, and so on. And this beautiful piece of art of mathematics is a Y Combinator, which allow us to have a recursion in a languages which doesn't have a natively support for the recursion. So these are the resources which I have used to learn about. I've been learning about for 2 days straight. And so here I want to talk a little bit about my Elixir Delhi community, which I'm building with my friend here in New Delhi. So these are the links you might be interested in. And the second link with t-me Elixir Delhi is our Telegram group, where we local people communicate about and learn more about like Elixir related tech. So thank you. that's all my talk.
All right. So you guys really, that's a real special talk there that we just heard. Mohd wanted to be here with us today, but he had some visa issues, and so he got up especially early for New Delhi. I think it's about 5 a.m. there right now. So really appreciate that, Mohd, again. Next talk, we have one, John Waba. John, you here? Give him a round of applause as he makes his way up.